In the expanding universe, we are told, and I have to believe it, that everywhere is, as it were, the same as everywhere else. There's no one place which is the edge of the universe. How can that be?
Well, Richard, first of all, you said you're told it, so you have to believe it. I will never require you to believe anything.
Good for you. Well done.
It will only ever be about how compelling is the evidence to you. We look around the universe and it looks like we're in the center. What an ego-supporting concept that is. You can either go around continuing to think that, feeling good about yourself, or study the problem and learn that in an expanding universe where the speed of light is finite at 186,000 miles per second. Forgive me using miles per second.
I prefer miles.
You do? You got that on tape. An Oxford professor.
No, it's true. Nobody talks about kilometers in Britain.
Oh, good. All right. So we share not only most of our language, we share miles still. And inchworms, what do they call them? They're not centimeter worms, right? They're inchworms.
We don't have that sort of stuff in Britain. That's Europe.
Of course, Britain is not Europe, as we're constantly reminded. That's right. Here we have the English breakfast and the continental breakfast.
Yes,
They're very different breakfasts that you can order here. So this horizon problem is actually quite simple. And rather than explain the full-up nature of it, let me just give a simple example that is entirely analogous. When you're a ship at sea and you look out, your horizon in every direction is the same distance from you. Depends on your height above the sea level. That's why ship decks are high. They see farther beyond the curvature of the earth than you do just standing on the main deck. So your horizon is a perfect circle centered on you. You can conclude that is the extent of the entire earth, or you can imagine, suppose I'm in another spot. Well, that horizon is still true for whoever happens to be in the middle of it, but now you've moved to a new place, and you will see a horizon corresponding with that spot. And so everybody has a horizon at sea, yet no one at any time is thinking that that's the full extent of the ocean or the full extent of the earth. We have a horizon in the universe, so does the Andromeda galaxy. The galaxies with names that look like phone numbers. We've got, if you travel to those galaxies, they will see the edge of the universe now in 3 dimensions, in every direction, at the same distance from them, just as we see for ourselves.
That does it for me, provided that the horizon is that which we are capable of seeing. I could follow that if you said that for any part of the universe, the horizon is the bit before the expanding universe has disappeared over the horizon.
Yes.
Which means it's no longer visible.
Yes.
No longer, but it's still there, even though we can't detect it.
It's true with the ocean when you're at sea.
Yeah, but is anybody on my side here?
You want it to be a harder problem than it is. I'm just simply saying, so here you go. Here you go. The radius to our horizon is about 14 billion light years.
Got it, okay.
Okay?
Yeah.
If we sat here, or return to this spot 1 billion years from now, that horizon will be 15 billion light years away.
Yep.
It's actually an expanding horizon because the light from 15 billion light years away, will have had time to reach us. Right now, it's still en route.
Yeah, I have no problem with that, but beyond the 14 billion year...
The problem is the universe wasn't born yet.
Yeah, okay.
That's the problem.
I know.
Okay? So you can't see the universe before it existed.
So why doesn't somebody...
Invent a kind of telescope that can?
No. Okay, I'm getting out of my depth here. Let's get back to...
No, just to clarify.
Okay.
Just to clarify. So it takes light time to reach us, and the universe hasn't been here forever. When you combine those two facts, you get an edge of the universe. And so the universe has been here for 14 billion years. The farthest thing that could send us any information is 14 billion light years away.
I get that, but what about the guys who are on the edge of what we can see? How can they see beyond the other side?
Oh, because here's an interesting point. We don't know whether or not the entire universe is infinite.
Okay.
And our horizon is, the universe could be twice our horizon or infinitely larger than our horizon. Same with the ocean. You don't know how much bigger the ocean is than your horizon is. You can keep sort of wandering around. Maybe you'll hit land, as we've done, of course. So now you go there. If the universe is really, really big, that will be the center of their own horizon. And whatever the age of the universe is for them at that time, that will be the radius to their horizon.
Yeah, okay.
Let's look at the cosmic abundance of elements. In the universe, the number one element is hydrogen. Next, helium. Next, oxygen. This is in order of abundance. Next, carbon. Next, nitrogen. Next, perhaps the most important element of them all, you see it in most lists, other. Yeah, there we go. Now, what about life on Earth? Let's see. What's the number one element in life on Earth? Hydrogen. Well, how does that happen? Well, because, as we know, at least, human life, you learn in biology class, is mostly water. And water is H2O. H2O. The H2. H is hydrogen. Okay? How about next? Oh, no, not helium. Why not helium? Well, because helium is noble. We learned that earlier this evening, didn't we? So helium is not in us. You could inhale it. You sound like Mickey Mouse, but it won't interact with us. So even if it were available to us, there's nothing you would do with it. So it's in the universe, but not in life because it's not chemically active. What's next? Oxygen. Next, carbon. Next, nitrogen. Next, together, other. Life on Earth is one for one, in sequence, made of the most common ingredients in the universe. And we are chemically based on carbon. We are carbon-based life. Why? It turns out that carbon is the most fertile element there is. You can make more kinds of molecules using carbon than all other kinds of molecules combined. So whatever chemical experiments are going on the surfaces of planets across the galaxy, if we find life anytime soon or ever, the chances are good that it's going to have carbon as its base, as its chemical base. And you combine all these elements in all kinds of interesting ways. Science fiction stories like talking about silicon-based life. Silicon sits directly below carbon on the periodic table, which means they bind similarly to the same other atoms. The problem is carbon is 5 times as abundant as silicon. You don't need silicon to make this work. Carbon is there for you.
What do you think are the odds that there is life elsewhere in the universe?
They must be high, and I'll tell you why. People say, well, have you found life yet? No. Well, that's like going to the ocean. This has been said before, taking a cup of water, scooping up, and saying, there are no whales in the ocean, Here's my data, You need a slightly bigger sample. And so if you look at, for example, what we call the radio bubble, this is the sphere around Earth, centered on Earth, which is the farthest our radio signals have reached in the galaxy. And they're about 70 light years away. We've been transmitting radio signals inadvertently leaking into space for about 70 years. 70 light year radius sphere. Well, how big is the galaxy? Well, shrink that sphere down to maybe the size of a BB, and then the galaxy on that scale would be the size of this stage. That's how far our radio signals have traveled. And those aren't even the ones we sent on purpose. The ones we sent on purpose have traveled much less. So no, we haven't actually reached as far into the galaxy as we'd like before we would say definitively that there's no one intelligent living today. But here's some very simple facts. I can review them in 90 seconds. You look at the formation of the Earth and the earliest sign of fossil life. Subtract a few hundred million years at the beginning of Earth, when Earth was a shooting gallery. Earth was still accreting the birth materials of the solar system. It's hostile to complex chemistry over that time. Not fair to start the clock then. Wait a couple hundred million years, now start the clock, and wait around and see when you have the first signs of single-celled life. At most, 400 million years. At most. Earth has been around for 4.5 billion? So Earth, without any help from us, with basic ingredients found throughout the universe, managed to create life, simple though it was. So, and Earth, one of, 8 planets, get over it. One of, sorry. Earth, an ordinary star, to suggest, and what are the ingredients of life? The number 1 atom in your body is hydrogen. Number 2 atom is oxygen, together making mostly water that's in you. Next is carbon in this order. Next is nitrogen. Next is other stuff. My favorite element, other, yeah. You look in the universe, the number 1 element in the universe is hydrogen. Next is helium, chemically inert, couldn't do anything with it anyway. Next is carbon. I think I left out oxygen there. Next is oxygen. Next is nitrogen, 1 for 1. We're not even made of odd things. The most common things in the universe are found here on Earth, and we're made of them. And carbon, one of the most chemically fertile element on the periodic table. It's not a surprise, we're carbon-based. Life is just the extreme expression of complex chemistry. So that's what biology is. So all these people who want to imagine, because they remembered their chemistry class, that silicon sits right below carbon on the periodic table. So it bonds similarly to carbon, so they want to imagine silicon-based life. I'm saying, okay, fine, but you don't have to. There's 5 times as much carbon in the universe as silicon. There's no need to even have to go there. We got enough to imagine just simply with the carbon atom at the center of these huge biological molecules. Point is, it happened relatively quickly with the most common ingredients in the universe. To now say life on Earth is unique in the universe would be inexcusably egocentric.
Yeah, I agree with that.
Oh, okay.
And I would go further and say that if ever you meet somebody who wishes to claim that he believes or she believes that life is unique in the universe, then it would follow from that belief that the origin of life on this planet would have to be a quite stupefyingly rare and improbable event. And that would have the rather odd consequence that when chemists try to work out theories, models of the origin of life, what they should be looking for is a stupendously improbable theory, an implausible theory. If there was a plausible theory of the origin of life,
it wouldn't be it.
That's right, because then life would have to be
everywhere.
Everywhere.
Yeah. So you're worried that you will die before aliens come visit you. Okay, there are hallucinogenic drugs that can solve that problem. And your brain won't know the difference. So here's the thing. If you want to communicate with intelligent aliens across the gaps of space, you would use things that move at the speed of light. Radio waves have good sort of penetration properties of interstellar gas clouds and this sort of thing. All right, so now let's find a planet and send a radio signal. Well, that radio signal is going to have to arrive there at a time where they have not only intelligence, but technology. Suppose some other civilization was sending us radio waves and it arrived 200 years ago.
Presumably, we would have counted ourselves among the ranks of intelligent creatures in the universe at that time, but we would have had no capacity to receive radio waves because radio waves weren't discovered yet. And so, in fact, if you want to communicate with a civilization, it has to be right in the slice of time where the life on that planet achieved complexity and intelligence and technology. And maybe technology is not a forever thing. Maybe technology escalates to the point where it becomes so dangerous that they render themselves extinct. So perhaps there's only a narrow window over which you could actually have a radio wave conversation with aliens. So I think the only hope, really, is that we get visited by highly intelligent aliens that figured out a way to cross the gaps of space-time, but thereby not being limited by the speed of light as a speed limit of the universe. As we say, speed of light is not just a good idea, it's the law. But if you warp space-time, you can cheat that, as they do in Star Trek with their warp drives and things. So if they would visit us. Now, you were depressed before. You don't know depression until what I'm about to tell you. So now imagine if they visit us in a spacecraft. What are we doing now? In the United States, we don't even have a spacecraft to launch our own astronauts. We're hitching a ride we're buying seats on the Russian for tens of millions of dollars, okay? And what will that do? It will go into low Earth orbit where we will boldly go where hundreds have gone before, all right? That is the state of human space exploration at this moment. Now aliens come from the gaps of space and they land. Okay. I have two hypotheses. Three. One of them is they have already landed, but they accidentally arrived during Comic-Con. And no one could distinguish them from any other costumes that were being worn. And then they left because no one cared that they came. So it's a remote possibility, but I'm allowing that in the probability of this. All right. So another possibility is that they took a good look at us and concluded there's no sign of intelligent life on Earth, not worthy of their attention. A third possibility, there may be more, but these are the three that I carry with me, is that they are so much smarter than we are. And by the way, what would that take? Not much. But what's the next closest animal to humans in intelligence? Chimpanzees, chimps. And what's the DNA difference? 2% tops? Yet, what's the most they can do? They can stack boxes and reach a banana? Okay, maybe they'll put up an umbrella, rudimentary sign language, maybe. Our toddlers do that. Our toddlers. So here's only a 2% difference in DNA, and the chimp is stacking boxes, but we have poetry and music and the Hubble telescope. So our hubris ends up saying, what a difference that 2% makes. What a difference that makes. Maybe that difference is just as small as the 2%. Maybe the difference between the Hubble telescope and stacking boxes is as small as the 2% indicates. Because now consider some other species, 2% beyond us, just as we are 2% beyond the chimp. What would we look like to them? They would roll the smartest human Stephen Hawking, roll him forward and say, this one is slightly smarter than the rest because he can do astrophysics calculations in his head, like little Timmy over here who just came back from preschool. Alien Timmy. Oh, look, you just composed your 12th sonnet. That's beautiful. Oh, you just re-derived the fundamental principles of calculus. Let's put it on the refrigerator door. Yes, that's what their toddlers would be doing because our toddlers do what the smartest chimps do. If aliens came and they had only that much more intelligence than us, the gap that is between us and chimps, and we have DNA in common, if they were only that, they could enslave the entire Earth and we wouldn't even know it. Maybe that has already happened. And we are living our lives as though we are expressing